I think we can start. Good afternoon, everybody. My name is Cindy Xing. I'm a software architect for Futurewei. And then specialized for public cloud service infrastructure. My interest area is in the edge computing. Currently, I'm leading the KubeEdge project. I'm also co-chairing with Dan on the Kubernetes IOT Edge workgroup.
Yeah, sorry, thanks. My name is Dejan. I'm a software engineer with Redhat. And I've been involved mostly with the IoT and messaging within the Redhat engineering team for the last couple of years. And also been involved in the Kubernetes IoT Edge working group where we try to frame some of these problems.
Okay, cool. Before we start the topic, let's do a quick survey. I want to know, can you give a quick show of hand? How many of you first time heard about KubeEdge? First time? Okay. How many of you have used KubeEdge? Run it? Oh, okay. Okay, this is out of my thought. Okay. So, I think we can move on then.
Mm-hmm. So, before we go to the project itself, let's, as you said, try to frame a problem a little bit, and what's the edge computing in general, and what are the challenges of doing edge computing. So, basically, as one of our colleagues, Steve, said, edge computing is everything. Edge is everything that's not in the cloud, right? So the idea is to try to put the workloads as close to the users and the devices that are using those workloads as possible. So we have a different types of edge infrastructure that we can deal with, but within the KubeEdge context and the IoT context, it's something we call the device edge, which is basically trying to externalize the Kubernetes nodes closer to the outside of the centralized data center and centralized cloud. What we gain by doing this? So there's a couple of use cases that are easily identified as a good candidates to be used in this way. So basically, you are dealing with improved latency in the responses to the input from the users or the devices. You have your data locality and improve the security of the overall system by processing data locally, not sending all the data to the centralized cloud. But also we are talking about dealing with the environments where these nodes, external nodes, have limited and really intermittent connectivity to the centralized cloud. So we need to provide a solution to provide autonomy of those sites for the workloads that needs to be run there. So this is all nothing new generally. So the thing is, why would we try to use Kubernetes in this context, and what that does bring us? And the belief here is that Kubernetes won the hearts and minds of a lot of developers. There's a big ecosystem of the tools and the infrastructure that people want to use. So why not try to use the same tools and same infrastructure that developers like and use, and just provide them to be able to deploy their workloads wherever they want. So being the centralized cloud, being the edge nodes, or even the whole edge clusters. So with those thoughts in mind, we started the Kubernetes IoT Edge working group. Just a quick, we have a session on that working group on Thursday, I think 4 p.m. So if anybody is more interested in that general topic, I would advise you to join us there. And we started the working group as a way to try to actually frame this problem, to see how to go there. and provide some basic reference architectures and implementations for this. This is where the Cindy and the KubeEdge project came in as well, and providing a basically reference implementation for one particular use case, and that's IoT Edge and basically solution for the device edge. So it's now a CNCF sandbox project, and Cindy will go on and give you more details about it.
Okay, so as what Dan mentioned, here we are talking about edge computing. Edge computing brought enterprise and customers a lot of benefits. Meanwhile, it has a lot of challenges. So what exactly KubeEdge is about? It's about the mission we are trying to enable is to enable enterprise or customers manage their resources at edge and also be able to orchestrate their applications at edge. Then, what's special about KubeEdge? In our mind, we want to use the same tool, Kubernetes, so that IT admin or users, they can manage their resources without knowing their edge node locations, no matter it's in data center or at the edge. That's first. Second is KubeEdge will follow or support the Kubernetes primitives. Nothing will be changed. And then meanwhile, we want to address all the edge workload technical challenges. Think about, for example, your work node might be behind the firewall. And also your work nodes, the network connectivity between the worker node and the cloud might not be reliable. And also the scalability of the worker nodes can be much bigger than the data center. We are talking about fleet of edge nodes and fleet of edge devices. And then everything integrate together. Imagining in the end, you are running a Kubernetes-based infrastructure to manage data center machines and also machines at edge and nodes freely in the sense of network, storage, and compute. That's what the end goal we're trying to achieve. Then let's talk about the current architecture. As you can see, KubeEdge currently is open sourced, both the cloud section and the edge section. In the cloud part, it's basically a Kubernetes control plane plus a couple of components, edge controller and cloud hub. And then on the edge side, because in the consideration of edge nodes are resource constrained, we made some changes based on kubelet. Currently, for the KubeEdge agent, the runtime memory consumption is only 10 megabytes. Think about it, it's much smaller than the kubelet itself. And then, on the other hand, this smart agent supports most of the current Kubernetes primitives. You can register your node, deploy applications, and then later on, we also plan to support service, endpoint, etc. Okay, so as I mentioned, also on the agent side, you can see multiple boxes. They're all modules. We have a pretty cool infrastructure, which I'm gonna deep dive on Thursday. The infrastructure is called Beehive, so that you can plug your modules. For example, for my edge workload, I'm not gonna support a device. Then you don't need to run those or configure those modules so that your agent can be even smaller. Another special thing I want to share with you about KubeEdge is the concept of KubeEdge is that you run your control plane on the cloud, and then your edge node is close to your data or close to your customers. So this way, the management overhead is much smaller comparing to if you run a whole cluster at the edge side. And then the other part I mentioned, the edge node network connection with the cloud might not be reliable. How can we address this? So KubeEdge supports autonomy of the edge node. The beauty of this architecture is we cache all the metadata on the edge side as well. As you can see, there's a data store on the edge side as well. So when the edge node is connected to the cloud, when it's linked, then all the customer's metadata, like say node, pod, all the information will flow down through Cloud Hub and Edge Hub to the edge node, and specifically for that edge node. After that, in case the edge node is disconnected from the cloud, since the data is cached, persisted on the edge side, then even without the network connection, everything, the business can continue running. So that's the beauty of this architecture. The other one I want to mention is, as I said, it's targeted specifically for that node. Think about currently when kubelet connects to API server, it watches all the pod for the cluster. And then kubelet will figure out which pod bound to that node and do the business. With this architecture, when Cloud Hub trying to flow down or send message to the edge node, it only sends the messages specifically for that node. So in that sense, we make sure that we can enable larger scalability because in that sense, the API server supposedly can support more nodes than current Kubernetes has. The other thing from a feature perspective I want to mention is currently KubeEdge supports device management, and also you can run, it also supports device twin on the edge side so that like you can deploy your IoT applications to the edge node. We also support the MQTT. So ongoing in the 0.3 release, we also enable the device CRD so that like you can even deploy your devices through the cloud to the edge.
Wait.
Okay.
Here it is.
So what's next? As I mentioned, like KubeEdge currently support most of the Kubernetes primitives. Then there are more challenges. As I mentioned, the Uber vision we want to enable is like microservice or service mesh, so that when you deploy microservices on the edge workload, things can just work as it's in data center. So the next we are investigating or innovating is around the service mesh area. If you look at Envoy, Linkerd, or network service mesh, there are a bunch of innovations in the community. So for example, Envoy is running the sidecar container within the pod. And Linkerd running a network proxy per node. And then network service mesh is allowing customers to configure their layer 2, layer 3 network. So for KubeEdge, what we plan to do is on each node, we are going to run a network proxy. And then on the cloud, we are also going to run another middle bridge network proxy. In this way, basically, we are setting up a routing infrastructure so that we can enable layer 7, layer 2, layer 3 service mesh without a problem. So this is just an architectural design. We haven't implemented yet. You are all welcome to participate and provide feedback. The next feature I want to address is edge side. As I mentioned, KubeEdge before, the original customer scenario we want to address is customer have their control plane on the cloud and worker node on the edge. But meanwhile, we got from KubeCon Seattle, we heard customers, they want to run clusters at their edge side. So the edge side design is basically for that purpose. The idea is like you can still have a Kubernetes control plane, but a new version of KubeEdge agent so that you can have a pretty lightweight Kubernetes cluster run on your edge side. Together with all the other features KubeEdge supports, for example, the device management, etc. Again, this is an in-progress feature. All the design doc is in GitHub. All of you are welcome to provide your feedback, contribute even. The third one I want to share is like, as I mentioned, edge computing, comparing with data center, the scalability can be much bigger. With the design of KubeEdge, we implemented a performance measurement framework. It's based on KubeMark, but it's targeted for KubeEdge. And then we've already finished the implementation, collected some performance data, but this effort is ongoing. The main goal is to make sure KubeEdge or Kubernetes cluster can support even more edge nodes and workload. So back to Dan, you can share more.
Yeah, so since the start of all this effort, I think in March the version 0.2 was released, and it contains the full open source versions of the both edge and the cloud parts of what Cindy previously discussed. And the current plan is to have like an early June release for the 1.0 release, which will add a little bit more features into it and also provide a lot more testing and scalability and performance testing. And finally, the future releases will include all the features that Cindy also mentioned before, like a service mesh and edge sites and things like that. So we can now talk a little bit about how the KubeEdge stands in the whole community. So the Kubernetes community, but also other open source IoT communities. So first and the foremost, the Kubernetes IoT Edge working group is the place where we basically discuss all the basic designs and principles and challenges around all this. So I think that's work is gonna get going for a while. Yeah. And also one of the things that KubeEdge doesn't solve all on its own is that layer of application layer of the IoT solutions, and that's where the Eclipse IoT community can come in hand, because there's a lot of projects there that can provide you with a lot of tools to put and develop an IoT solutions in kind of a cloud native ways. So first one I would mention is Eclipse Hono, which is connectivity layer for the IoT messaging. If you go a couple of slides back and showing the basic architecture of the KubeEdge, we have these things here where the event bus connects to the MQTT broker. So that is one way, one integration point we can do for the KubeEdge and Eclipse Hono. We're basically connecting KubeEdge applications running on the edge to the cloud connectivity platform. Also, the digital twin project within the Eclipse Ditto, is also one of the candidates to integrate with the edge side of the digital twin running on the KubeEdge. Additionally, in the Eclipse community, we have a Eclipse IoT Fog project, which focuses on developing microservices, developing a microservice framework for the edge computing, and I think there's a lot of possibilities for collaboration in that area. But even edge computing is becoming like a interesting topic. So there are working groups popping up everywhere. Acroino is one of the interesting working group within the Linux Foundation that provides a lot of blueprints for different scenarios of edge computing, and some of these blueprints will include KubeEdge implementation in the future. There's also LF-Edge Foundation that you could find it interesting if you're interested in this topic.
So all the KubeEdge information can be found here. We also have a KubeEdge computation. If you participate, and then you can even potentially get a free ticket to KubeCon Shanghai this year. So again, like in the end, no matter KubeEdge itself or the Kubernetes Edge IoT workgroup, mainly is to enable the community and meet all your needs. So you are all welcome to participate and contribute. Do connect me or Dan if you have any question or comments. So do you guys have any question or comments?
Thank you. So it's about scalability. You mentioned that you are having the 1.0 release May, June this time. Do you have any preliminary results or any targets? What do you want to achieve? When it comes to
scalability.
Yeah, okay. So from an architectural design perspective, theoretically, KubeEdge should have a better scalability comparing to the current Kubernetes. The reason, as I mentioned, because in Kubernetes, each kubelet needs to maintain multiple watches against API server. But with this design, only the edge controller is doing the watch. And then we use message flow to send down all the metadata to edge workloads. So that's a theory. We are still measuring the data. So far, we are still validating the concept. The goal would be, back to your question about the goal would be at least on par with Kubernetes. We want it to be better. So Kubernetes currently, one cluster supports up to 5,000 nodes. We are hoping this can be even bigger. Yeah.
Thank you.
Hi. Just to understand, so you are not making nodes, but you are making custom resource definitions, or like they are also nodes, but that's some sort of change in the API. Sorry.
Okay. So in Kubernetes, the node is a logic concept, right? So basically, you create a YAML file, then you can register the node. So then from that perspective, KubeEdge agent is the same. So for the KubeEdge, once you install the agent, and then on the cloud, you author a node YAML, and then you register the agent. Once the agent connects to the cloud, then it's just working. And then meanwhile, for the KubeEdge agent, we just rewrite kubelet, remove all the unnecessary code. For example, we are not statically linked to the Docker shim. So then it's much lighter. As I mentioned, the KubeEdge agent, the runtime memory footprint is only 10 megabyte. Yeah. Okay. Any other question? Any other question, comments?
Thanks for the great presentation. So have you evaluated K3S from Rancher, and how do you think about it?
Okay. I'll first share and then can add if I miss anything. So tomorrow or Thursday afternoon, there will be a Kubernetes IoT Edge Computing workgroup presentation. We will talk more about this. But the short answer is there are 2 points. First of all, for KubeEdge, the original design is the cloud control plane is on the cloud, and then edge node is on the edge. And then for Rancher K3S, the targeted customer scenario is to run the whole cluster at the edge. So from a customer scenario perspective, they are targeted different things. That's first. Secondly, as I mentioned in the slide deck, for the edge side design, we are also covering or enabling KubeEdge to run a cluster on the edge. So, and then plus the agent talk to the cloud using the same Kubernetes API protocol. So in that sense, the KubeEdge agent can talk to a K3S server without problem. So then together you can benefit from the lightweight K3 server as well as the KubeEdge agent. Yeah. Any?
So for the intermittent network connectivity, does your KubeEdge, how does it use the local cache? Is there sort of an equivalent Kube API server there? So if you don't have connectivity to the Kube API server because network is not available, how does KubeEdge work?
So as I mentioned earlier, because in the Kubernetes control plane, you have an API server and backend etcd, right? So etcd store all the customer deployment metadata. And then through the KubeEdge architecture, all the metadata data flow down to the edge side and persisted to the local store. So all the customer deployment need is already there, and it's already scheduled to that node. Once the network is disconnected, the KubeEdge agent will just watch to the local store and then take all the action, orchestrate with Docker or whatever container runtime. That's how we, so basically through the mirroring of the 2 data store as well as the message channel, we achieved the autonomy and network disconnection or reconnection scenario. Yeah.
How do you manage the network overlay when, you know, obviously edge devices are going to be geographically dispersed, and making sure that pods aren't scheduled onto, you know, somewhere it shouldn't be?
Yeah, that's an excellent question. So if you go to GitHub, right now for KubeEdge, we are using Docker host network right now. The assumption is because the edge node is resource constrained, we don't foresee people run a lot of pods on the edge node. That's why we use the host network on the edge side. Then we are also assuming all the edge nodes are on the same subnet. Because from a Kubernetes perspective, the network assumption is it's a flat network, right? So that's the current stage. But in my deck, there's a service mesh design, right? So later on, using the per node network proxy and the cluster level proxy on the cloud, we want to enable or cover all the possible network topologies. For example, in case your edge node is behind the firewall, are we going to enable a VPN or tunneling? And then in case of network disconnected, the west-east, how can I enable the two nodes talk to each other? So essentially, we're using all the proxies to enable the routing, VPN tunneling, etc. Yeah. Okay. Any other question, comments? So I think
we have one more. I think we have time for one more. And
just a question to see if I correctly understand the purpose. You are never able to force a workload to run on an edge. You never select the edge. You just say run the workload. You don't have any affinity capabilities or things like this to select the edge you want to run on.
So if I understand your question, you're saying I can select different edge node to deploy my application. Is that right? So it's going to be philosophically, it's going to be the same as the existing Kubernetes cluster. We can use the label selector, just label your node and then deploy your. It's the same. So the beauty of this architecture is to cover all the technical challenges for edge computing, but maintaining the same principles for Kubernetes. Same primitive, same API, everything works the same. You just not transparent of the location of your nodes.
So you can do that basically by having taints on the nodes and affinities for the pods, and that will make them go to the right place.
Again, thanks for coming. And then Thursday, we have 2 talks. One is for the Kubernetes Edge Computing Workgroup. It's a long talk. Then secondly, Thursday, we have a KubeEdge deep dive. If you're interested, I welcome you to come again. Thank you.
Thank you for coming.